Hello everyone, welcome back to my channel, that is Mathematics Scholar. I hope you all are doing good. Please watch the video till the end so that you'll get clear idea of the proof. And also if you are new to my channel, please subscribe to my channel and also press the bell icon so that you'll get all sort of a notification whenever I upload my new video. So in this video we are going to prove the theorem which is based on congruence, and they'll ask for 2 marks, and it is also very important and it is very simple to understand also. So let's start with the proof. As you can see on the screen, the statement of the theorem: if R is a remainder on dividing A by M, then A is congruent to R mod M. The meaning of this one is whenever A is divided by M, we'll get quotient as Q and remainder as R. In such scenario, we can have A is congruent to R mod M. By the definition of congruence or congruent, I can have, or the meaning of this one is nothing but M divides A minus B. It's as simple as that. Let me pick one example over here so that you'll get a clear idea of this theorem. Let me take the value of A as 4 and M as 2. Okay, whenever I divide this one, I'll get the quotient as 2, that is 2 2s are 4, and this is 0, and the remainder as R. So in such scenario, when A divided by M, we'll get the remainder as R. In such scenario, we can have A is congruent to R mod M. A is congruent to R mod M. In this case, in place of B, I should have R. Okay, I should have R. So this is if and only if this can happen, or with the definition of congruence, that is M divides A minus B. So what is the value of M? M is 2. M is 2. What is the value of A? A is 4. Again I have written B here, sorry. It is R. I'll just rub this one. It's R. So what is the value of R? R is 0, right? R is 0. So this implies 2 divided by 4, and what is the meaning of this? 2 divided by 4 is nothing but 4 is divided by 2, and it get cancelled for 2 times. So it is satisfying this condition. So since it is an if and only if relation, I can write down A is congruent to R mod M. So with the definition, I can prove this one, that is A is congruent to R mod M with the definition of congruency. So that is the idea of this one is as simple as this, where M is a positive integer and A can be any integer. That is the idea. So let's prove the theorem. So let me start the proof over here. If R is a remainder on dividing A by M, I am supposed to prove A is congruent to R mod M. So let me write down here, since R is the remainder on dividing A by M, Therefore Therefore, I can write down by division algorithm A is equal to MQ plus R, where Q is the quotient, R is the remainder. Okay. As you can see here, the division algorithm I have written here for any given integer a and b where a is not equal to 0, there exists unique integers q and r such that b is equal to aq plus r, where r lies between 0 and positive a. Okay, that is the simple thing. In simple thing I can state that this is dividend. Dividend is equal to divisor into quotient plus r. Whenever you divide something, you can represent in this form. That is the meaning of division algorithm. So I'll just write down since by since by division algorithm division algorithm or this I can write it down as, I'll shift this r to the other side. I'll shift r to this side. So what I'll get? I'll get a minus r is equal to mq. Therefore, by definition of divisibility, I can write down divisibility. I can write down this one as m divides a minus r. M divides a minus r. As you can see here, the definition of divisibility also have written here, that is, let a and b be any integer such that b is not equal to 0, then b divides a in the sense in this form, b divides a if there exists integer such that a is equal to b, where a can be written as the multiple of b. Okay, so that is the thing, it's very simple. So in that case, I can write down this as, by the definition of divisibility, as m divides a minus r. So there it was just a, here it is a minus r. So that's the thing. Hence I'll write it clearly. Hence a is congruent to r mod m. Again, with the definition of congruency, you can write down this one. You can see here I have written, let m be a positive integer if a and b are any two integers such that m divides a minus b. This is very important. M divides a minus b. Then a is said to be congruent to b mod m. So this is the thing. Here in place of b, I have r. Here in place of b, I have r. That's the difference. So by the definition of congruency, I can write down this as a is congruent to r mod m. You can just write down, since by definition of congruence. It is as simple as that. See, it's very simple and it is very easy to understand. Okay, that's the proof of the theorem. Please make a note of division algorithm, divisibility and congruence, what I have written here. If you're still feeling difficult to understand this particular concepts, you can watch my previous video where I have explained all these things in detail. Okay, thank you everyone. I hope the theorem proof what I have explained here, it is clear for you, you have understood. Please like and subscribe to my channel, and also share this particular concepts to the person who is doing B.Sc, M.Sc or engineering, who needs such concepts to get understand very clearly. So if you have any doubts, you can comment me in the comment section. Okay, thank you, have a nice day, bye bye.